Okay, question 4, we have to simplify these, and that's lending you to think towards using your trig identities. So we don't often see like to cos to the power 4, but that's just like cos squared times cos squared. Now I personally don't ever do this, but what you could do is you could treat it like this. Oh, sorry, I'll just rub that out. So all I'm doing here is simply changing the cos theta for an x, and if I change the sine, I can't use an x as well because they're different, so let's use a y. Now when you look at something like that and I said what can you do to it, you should be thinking of factorizing, and because there's no x, y's in here, you should realize this is a factorizing by the difference of two squares. So let's do this one down here. So if we think about what if it was x to the power 4, it'd be x squared times x squared, but it's cos to the power 4, so it's going to be cos squared theta and cos squared theta, and that would give me cos to the power 4 theta. And again, at the backs we're going to have sine squared theta and sine squared theta. Now with the difference of two squares, you should know that the signs have to be different so that they eliminate these middle terms. Okay, so if we look at this one here on the right, you should notice you can use one of your trig identities, and we know that that is identical to 1. So actually it's just equal to this. But don't stop. Can we go further? Now let's take this one for example. Let's take that, and you should be able to tell me that cos squared theta, well, that's the same. Using this same identity, cos squared theta plus sine squared theta is equal to 1. You should be able to tell me that's 1 minus sine squared theta. Okay, that's that. So let's add this bit on. It might be nice to write using sine squared theta plus cos squared theta is identical to 1. I haven't in here, but let's tidy this up now. So you've got 1 minus sine squared theta, take away another sine squared theta. Well, that's going to be 1 minus 2 sine squared thetas. Okay, so let's now do part B up here. So you should see there's two terms, but actually we've got something common to both terms. We've got this sine squared 3 theta. So when we've got something in common, we can factorize by taking that outside. Okay, so that's just going to be 1, take away, and what we're going to have to multiply by to make this? Well, cos squared 3 theta. Right, so here, again, we can apply that same trig identity that you know that 1 minus cos squared 3 theta, that is the same as sine squared 3 theta. The angles, this sometimes can confuse people, but as long as these angles are the same, that identity will work. So actually what we have is sine squared 3 theta being multiplied by sine squared 3 theta. So that times by itself. If you think of your indices knowledge, you can add these powers. So that's sine 4 3 theta. Now in part C is actually very similar to part A. You've got the same first term, you've got the same last term, but there's not a negative. And you've also got these middle terms. That's what I was talking about here with like the x, y terms. So we can factorize it definitely with two brackets, but this time it's not a difference of two squares, it's a normal factorizing. So potentially a little bit harder. So make your brackets quite big. So let's worry first of all about making this cos 4 theta. So that's going to be cos 2 theta multiplied by cos 2 theta. And again, this last term, just from your basic factorizing, you know that these last two terms multiply together to make this last one here. So that's going to have to be sine 2 theta and sine 2 theta. Sometimes I say 2, sometimes I say squared. I should be saying squared. And this is positive, so these both have to be the same. Now, everything's positive in here, but let's think about it. So, if you multiply this first term by the last term, and these two inner terms together, you're going to get a sine squared cos squared theta, okay? Which is this term here. But we've actually got two of them, and that's handy because there's one of them and there's the other one. So that is equal to this. Now, what you should be able to see is, using your trig identity, well, that first bracket, that's just equal to 1. And that's also equal to 1. So we're ending up with 1 times 1, which is 1. So this whole complicated looking expression is just equal to 1.